Hello, welcome to everyone in my YouTube channel. Today I am going to discuss cylindrical coordinate system where I will derive the expression for the gradient, curl, divergence and the Laplacian. We have already derived the general expression for the curvilinear coordinate system, and now these are the special cases. In your examinations you will be actually asked to find the divergence or chord or Laplacian in the cylindrical coordinate system. So that's why let us start. Any point in the cylindrical coordinate system can be written as like this. Okay, so this is the uh, rho and phi and z. Actually, in case of the curvilinear coordinate system, we actually denote the those coordinates by u v w or u1 u2 u3. Okay, here in this case rho represents the radius of the cylinder. Phi is the angle made by the radius with the x-axis, and z represents the length. Okay, so now the transformation relation between the Cartesian coordinate system and the cylindrical coordinate system are x is equal to rho cos phi, y equal to rho sin phi, and z equal to z. Then let us find dx. Then dx will be can be found by using the product rule. So u dv by dx plus v du by dx. Okay, so rho the derivative of the cos phi is minus sin phi d phi plus here it's like that. Okay, in the similar way you can actually find dy and the z dz. The line element is given by ds square is equal to dx square plus dy square plus dz square. We know this formula. Ds square is equal to, now put the values of dx, dy and dz over this equation, and then rearrange the terms. Okay, rearrange the terms. When you square this, some terms will be cancelled out because there is the minus will become here from here, plus will become from here. When you square this, and by solving you will get like this. Okay, so d rho square plus rho square d phi square plus dz square. Let us suppose it is equation 1, and as there is no any coefficient, we can actually write 1 here, because we can say that if there is no any coefficient, it should be 1. Okay, so now in case of the orthogonal coordinate system, okay, any line element can be written as like this. Ds square is equal to h1 square du1 square, h2 square du2 square, h3 square du3 square. Now it is going to be very important. You actually need to remember this one. Okay, so here, as like in case of curvilinear coordinate system, we have u1. So now in this case we have rho. Okay, where in curvilinear system we have u2. Now here we have phi, and in the same way we have u3 over there in the curvilinear system. Now in this case u3 should be equal to z, and if you compare the coefficient, like h1 square is equal to 1, h2 square is equal to rho square, and h3 square is equal to also 1. So what you can actually write, u1 is equal to rho, u2 equal to phi, and u3 equal to z. In the similar way, h1 is equal to 1, h2 is equal to rho, because the square will be cancelled out, and h3 equal to 1. After knowing this, you just need to know the general expression of the gradient. Now you do not require to derive the relation, because we have already proved this or derived this in case of the curvilinear coordinate system. Now nabla phi or the gradient is equal to e1 cap by h1 del psi by del u1 plus e2 cap by h2 del psi by del u2 plus e3 cap by h3 del psi by del u3. Now if you put the values over here, in place of the e1, actually you can write e rho, for it actually means the unit vector actually. So unit vector for the coordinate phi, rho. Okay, del psi by del u1 means rho. Okay, similar way put the value of e2 means e phi. Okay, e phi, and h2 means h2 means we have found the value of the h2 as rho. So and here also E3 is equal to E3 Ez, and S3 is equal to 1. Now if you um, just put the terms in the appropriate order, and this will be your Nabla-Bhai. This is the expression for the gradient. Okay, so now let us let us derive the another expression for the divergence. Okay, divergence of the vector function. So let we have actually any vector like a is equal to here we do not write I cap, j cap, k cap, because I, j cap is generally for the Cartesian system, but now it's for the general coordinate system. So a1 e1 cap, a2 e2 cap, a3 3 cap. So we know the relation nabla dot a means divergence. This is the general expression we have derived. 1 by s1 s2 s3 del by del u1 a1 s2 s3. It is quite easier for remembering also. So the terms are in the cyclic order. Okay, a1 s2 s3, then 2 3 1, then 3 2, 1 2, like this. Okay, so now put the values. We have already found a1 the value of a1. You can actually just put a1, or as the one coordinate is related to the row, so that's why I have replaced this by a row, a2 by a5, and a3 by az. So s2, put the value of s2 s3. Okay, u1 u2 u3, and just put the values over here, and you will get the general expression like this. Now let us see the curl of the vector function. To find the curl, we have the vector like this, and this is the general expression. This is the general expression for finding the curl. So nabla cross a is equal to this one. So now we now also put the formula, like also put the value e1. E1 means e row, e2 means e phi, s2 means row, e3 means ez1. Similar way, del by del row, del by del phi, del by del z, and put the values of a1 a row, a2's value is a phi, and a3's value is. It is not necessary actually to write. You can just write the value of a1 as a1 only. It's not mandatory. You can just write only a1 also, but if possible, because the one coordinate, first coordinate, is related to the row, so that's why I have replaced that one by a row, and this is for the 2, and this is for the 3. Okay, so when it is not necessary to show the expansion of this relation. This is the determinant, 3 by 3 determinants, quite difficult to show over here. Now let us discuss the Laplacian. In case of the Laplacian also, we have the general formula. Nabla square is equal to this is the formula, general formula, del by del u1 s2 s3 by s1, del by del u1. These terms are also in the cyclic order, so it's not also very difficult for remembering. Then s3 s1 by s2, these are in cyclic order. Okay, so del by del u1, del by del u2, del by del u3. Now just put the values. Now here just put the value of s1 s2 s3 over here, and in a similar way you just put the u1 means a row, and u2 means phi, u3 means z. Okay, so similarly put the value of s1 s2 like this. If you solve, and this is the general expression. This is the expression for the Laplacian in the case of the cylindrical coordinate system.